My dear students, in my previous video, I have started the State Board Mathematics 12th Standard subject first chapter, Applications of Matrices and Determinants. In this topic, I explained that matrix, rank of a matrix. How to find the rank of a matrix, that we have seen in our previous video. I have defined the rank also and how to find the rank of a matrix. But in this video, I am going to solve the matrix inverses. I am going to find out the inverse of a given matrix by using Gauss-Jordan method. I am going to find out the inverse matrix of a given matrix by using Gauss-Jordan method. You know, suppose A is a matrix and B is another matrix. If you multiply these two, gives you an identity matrix. Suppose it is of A and B or matrix of order n. A into B is identity matrix of order n. Then we say that B is equal to inverse of A. B is the inverse of the matrix A. That is A into A inverse equal to I into n equal to A inverse into A. You know, this is our property of inverse of a matrix. If you multiply a matrix by its inverse, gives you the identity matrix. Suppose B, A into B is identity, it means that B is the inverse of the matrix A. We have to find out the inverse of the given matrix A by using Gauss-Jordan method. What is the Gauss-Jordan method? Suppose A is a matrix of order n. So A into identity matrix, it's a matrix A and In is after row operations on A, operating rows operation on A, row operations on A. Row operations on A gives you this. After operating this row operations on A, this A becomes identity matrix and it is this matrix In become inverse of A. So A and In is after operating row operations on A, this A reduces to the identity matrix of order n, and automatically that In reduces to the inverse of the matrix A. Or otherwise you multiplying both sides by A inverse. A inverse into A you know. A inverse into A you know In. Similarly In into A inverse is A inverse. So like that, this is the concept behind in the Gauss-Jordan method. The given matrix A and the corresponding identity matrix are considered, and operating rows operation on that matrix A, given matrix A, and convert into the identity matrix, automatically the identity matrix becomes the inverse of the matrix A. So this is the idea, and we are going to solve some problems also using this Gauss-Jordan method. First I am going to find out the inverse of 2 by 2 matrix. Okay. Find the first problem. Find the inverse of the matrix A. Find the inverse of the matrix A. 2 minus 1. 5 minus 2. 2 minus 1, 5 minus 2. Find the inverse of the matrix A, given matrix A, 2 minus 1, 5 minus 2, by Gauss-Jordan method. That's our problem. You know, Gauss-Jordan method is A into I2 because this is of matrix of order 2. Therefore, what is A? 2 minus 1, 5 minus 2. into A, identity matrix 1, 0, 0, 1. So I operated on I2, that is I2 minus 1, 5 minus 2, and I2 is 1, 0, 0, 1. You convert this A into I, automatically this I becomes the inverse of the matrix A. Okay? See, first I am going to rewrite this second row to first row and first row to second row. I am rearranging the rows of the matrix A, R1 to R2 and R2 to R1. So I get R1 becomes R2, R2 becomes R2, 5 minus 2, 2 minus 1. So automatically this matrix is also you have to change R2 to R1 and R1 to R2. Okay, these are first step. The next 1, 0, 0, 1, you have to convert this matrix into identity matrix. For that R1 minus 2 R2. R1 is R1 minus 2 R2. This 5 becomes 1. After giving this operation R1 is subtracting 2 into R2 from R1. That is R1 is 5. 2 into R2 is 2 2s are 4. 5 minus 4 is 1. 3, 2, R1 is 5 minus 2 times of R2. 2 times of R2 is 2 2s are 4. 5 minus 4 is 1. Similarly, R1 is minus 2. 2 times of R2 is 2 into minus 1 minus 2. Minus 2 minus of minus 2 is plus 2. Minus 2 minus of R2. 2 R2 is minus of minus plus R2. Minus 2 plus 2 becomes 0. So second row as it is you get 2 minus 1. Similarly, the same operation is to be operated on the identity matrix also. R1 minus 2 R2. So R1 0 minus 2 R2 is minus 2. 2 into 1 is minus 2. Similarly, R1 minus 2 into 0, 0. 1 minus 0 is 1. It is draw as it is, you are right. And next, you divide R2 by minus 1 or multiply by minus 1. R2 by minus 1. So next step, you divide R2 by minus 1, that becomes 1, 0. First row as it is you get. Second row, 2 by minus 1 is minus 2 and minus 1 by minus 1 is 1. So 1, 0, 1 we derive 1, 0, 1. And we have to convert this minus 2 only to 0, then it becomes identity matrix. So similarly here, minus 2, 1, divide R2 by minus 1. Right side matrix also you have to divide R2 by minus 1. 1 by minus 1 is minus 1, 0 by minus 1 is 0. Okay, next R2 becomes now. This becomes, you have to convert this to 0. For that, R2 is R2 plus 2 R1. R2 is minus 2 plus 2 times of R1. You multiply R1 by 2, you will get 2 into 1 is 2. This is minus 2. Adding 2 plus minus 2, you will get 0. So after giving this operation, this is 1. First row is as it is, right? Second row R2 plus 2 times of R1. 2 times of R1 is 2 into 1, 2 minus 2 is 0. And 0, R2 is 1 plus 2 times of 0 is 0. 1 plus 0 is 1. So this becomes identity matrix. Similarly, here minus 2, 1. Here also R2 plus 2 times of R2, 2 times of R1, sorry. 2 times of R1 is 2 into minus 2, minus 4. minus 4 plus 1 is minus 3. Minus 4 plus 1. 2 times of R1 is minus 4 minus 1. Oh, R1, 2 times of R1 is 2 to the minus 4 and minus 1 is minus 5. Sorry. R1, R2 minus 1, 2 times of R2 is minus 4, adding minus 5. And R2 0, 2 times of R1 is 2, 2 plus 0 is 2. So this is of the form I2 into A inverse. So this is the form I into A, I slash I2 becomes I2 what? A inverse. So A inverse, we have defined that the required A inverse is minus 2, 1, minus 5, 2. This is our required inverse matrix of the given matrix. Minus 2, 1, minus 5, 2 is a required inverse of the given matrix. That's all about the method of finding the inverse by Gauss-Jordan method. Okay? Now, next problem in the exercise 1.2. Now I am going to find out the inverse of a 3 by 3 matrix. In the previous problem, we have seen the inverse of 2 by 2 matrix, but it is a 3 by 3 matrix given. We have to find out the inverse of this matrix by using Gauss-Jordan method. So Gauss-Jordan method is A bar I3, because it is a identity matrix of order 3 equal to what is A? 1 minus 1 0, 1 minus 1 0, 1 0 minus 1, 6 minus 2 minus 3. Identity matrix is 3 by 3, 1 0 0, 0 1 0, 0 0 1. Now we are convert this matrix into identity matrix. For that we are making this element to 0 and this element 2 zeros we have. Second row first element, third row first element. For that I am operating R2 is R2 minus R1. R2 is R2 minus R1. 1 minus 1 0. Similarly R3 is R3 minus 6 R1. R3 minus 6 R1. 6 times R1 is 6. 6 minus 6, 0 you will get. So by giving these two operations, first 1 minus 1 0, first row as it is, right? No change in the first row. Second row is R2 minus R1. R2 minus R1. 1 minus 1. 0. 0 minus of minus 1. Plus 1. Minus 1. Minus 0. Minus 1. Similarly R3 minus 6 R1. R3 minus 6 R1. 6 R1 is 6. 6 1 is 6. 6 minus 6. 0. Similarly 6 R1 is minus 6 into minus 1 plus 6. Minus 2, minus of minus plus 6, minus 2 plus 6 is 4, and R3 minus 2, minus of minus plus 6, 6 minus 4 is minus 2 is 4, okay, and R3 is minus 3, 6 times of 0 is 0, so minus 3 minus 0 is minus 3, okay. R3, 2. Good. Next, similarly, the same operations you have to change in the identity matrix also. First identity matrix is 1 0 0. R2 minus R1. R2 minus R1. 0 minus 1. Minus 1. 1 minus 0. 1. 0 minus 0. 0. Next, R3 minus 6 R1. So R3 0. Minus 6 R1 is minus 6, 0 minus 6 is minus 6, 0 minus 0, 0, and 1 minus 6 into 0, 0, 1 minus 0 is 1. Okay. Next, you have to convert this element to 0. For that, R3 is R3 minus 4 R2. R3 minus 4 R2 becomes, this element becomes 0. So next operation is R3 is R3 minus 4R2. So that is R3 is 1 minus 1 0, as it is you write 1 minus 1 0. Second row also 0 1 minus 1. Third row you have to change R3 0 minus 4R2. 4 times of 0 is 0. 0 minus 0 0. 4R3 minus 4 into R1 is minus 4. 4 minus 4 is 0. And R3 is minus 3. Minus of minus 1 is minus plus 4 times minus 4 into minus 1 is plus 4. 3 minus 3 plus 4 is 1. Next 1 0 0 as it is right. Second row minus 1 1 0. And third row R3 minus 4 times of R2. Minus 4 into 1 is plus 4. 6 plus minus 6 plus 4 is minus 2. And R3 0 minus 4 is 0 minus 4. Minus 4. And R3 1 minus 4 into 0 is 0. 1 minus 0 1. Okay. The next, you add R3 and R2. R2 becomes R2 plus R3. If you add R2 plus R3, this term becomes 0. 1 minus 1, 0. So I am giving this operation R2. Row 2 is row 2 plus row R3. For that, just 1 minus 1, 0. 0, 1 minus 1 and R2. So R2 you have to change, it's not. R2 plus R3, 0 plus 0, 0. 0 plus 1, 1. 1 minus 1, 0. And 0, 0, 1. Here we will get 0, 1, 0, 0. Okay. Here, similarly, you get R2 plus R3, 1, 0, 0, minus 1, 1, 6, or R2 plus R3. You have to write R2. R2 plus R3, minus 1, plus minus 2, minus 3. 1 minus 4, minus 3. 1 plus minus 4. 0 plus 1, 1. And minus 2, minus 4, 1. Okay. Next, finally, we convert this element to 0 for that. R1 is R1 plus R2. R1 is R1 plus R2. So you have to change R1 plus R2. You have to add R1, R2 and write it in R1. 1 plus 0, 1. Minus 1 plus 1, 0. 0 plus 0, 0. Next row as it is 0, 1, 0. 0, 0, 1. Similarly, R1 plus R2. R1 minus 3 plus 1, minus 2. 0 minus plus minus 3, minus 3. 0 plus 1, 1. And minus 3, second row as it is right. Third row is also as it is right. So this is the inverse matrix of the given matrix A. Minus 2, minus 3, 1. Minus 3, minus 3, 1. Minus 2, minus 4, 1. This is the inverse of the given matrix A. Therefore, A inverse is equal to, I am writing the answer here. So, after applying Gauss-Jordan method, this has become IN into A inverse. Therefore, A inverse equal to, we determined A inverse equal to minus 2, minus 3, 1. Minus 3, minus 3, 1. minus 2 minus 4 1. This is our required inverse matrix of the given matrix A. Okay, that's all about the problem. Next we will solve the same problem 3 by 3 matrix, and I have to find out the inverse of this matrix by using Gauss-Jordan method. It is in the exercise 1.2, third subdivision of the third problem. A is the given matrix 1, 2, 3, 2, 5, 3, 1, 0, 8. By Gauss-Jordan method, A power I3 is A and identity matrix of I3 1, 0, 0, 0, 1, 0, 0, 0, 1. I operate R2 minus 2R1 and R3 minus R1. So 1, 2, 3, you keep R1 as it is, you write R2 minus 2 times of R1, 2 minus 2, 0. R2 minus 2 times of R1, 2 2s are 4, 5 minus 4, 1. R2 minus 2 times of R1, 2 times 2 3s are 6, 3 minus 2 times of R1 is 3, 2 3s are 6, 3 minus 6 is minus 3. Next operation R3 minus R1, 1 minus 1, 0, 0 minus 2, minus 2, R3 minus R1, 8 minus 3, 5. Same operation on the identity matrix, 1, 0, 0, R2 minus 2 R1, 0 minus 2, 1 into minus 2. R2 minus 2 times of 0, 1 minus 0, 0 is 0, 0, 2, 0, 0, minus 0. Similarly, R3 minus R1, 0 minus 1, minus 1, 0 minus 0, 0, 1 minus 0, 1, R3 minus. Okay, next R3 is R3 plus 2 times of R2. Next I am going to convert R3 is R3 plus 2 times of R2. R3 plus 2 times of R2. For that I get 1, 2, 3. R1 as it is. R2 is also 0, 1 minus 3. R3 is 2 times of R2. 0 into 2, 0 into 0, 0, 0 plus 0, 0. Minus 2, 2 times of R2 is 2. Minus 2 plus 2, 0. 5. 2 times of R2 is 2, 3, minus 6. This is 5. R2 minus 2 times of R3 is minus 6. Minus 2 into what is that? R2 minus R3 plus 2 R2, sorry, R3 plus 2 to 0. R3 is 5 minus R3 plus 2 times of R2 is minus 6. 5 plus minus 6 is minus 1. Okay, 5 plus minus 6 is minus 1. 1, 0, 0. Minus 2, 1, 0. And R3 plus 2 R2. R3 minus 1. 2 R2 is minus 4. Minus 1 minus 4 is minus 5. R3 is 0 plus 2 times of R2 is 2. 0 plus 2 is 2. And R3 is 1. 1 plus 0 is 1. Okay. Next, I divide R3 by minus 1. This becomes plus 1. That is 1, 2, 3, 0, 1, minus 3, divided by minus 1, 0, 0, 1. Here also you 1, 0, 0, minus 2, 1, 0, you divide R3 by minus 1, you get 5, minus 2, minus 1. Here I am dividing R3 by minus 1. Okay, I will get this step. Next one, R3 R3 is R3, 3 R3 plus R2. R3 is 3 R3, 3 times of R3 plus R2. 3 times of R3 is 3. 3 plus minus 3 is 0. This becomes 0. R3. That's all. We want R2, not R3. Because identity matrix is 0, 0, 1. This minus 3 becomes 0 for that. R2. R2 is R2 plus 3 times of R3. R2 plus 3 times of R3. That is 1, 2, 3. 0, 3 times of 0 is 0. 0 plus 0, 0. R2, 1 plus 3 times of 0 is 0. 1 plus 0, 1. R2 is minus 3. 3 times of R3 is 3. Minus 3 plus 3, 0. And 0, 0, 1. So you get 1, 0, 0. R2 plus 3 R3. R2 plus 3 R3. 3 R3 is 3 5 are 15 minus 2. That is 13. 15 minus 2 is 13. R2 1. 3 times of R3 is minus 2 into 3 minus 6 plus 1. Minus 5. Minus 6. 3 times of R3 is minus 6 plus 1 is minus 5. Similarly, R2 is 0. 3 times of R3 is minus 3 into 0. Minus 3 plus 0 is minus 3. Next step, 5 minus 2 minus 1. Okay? Next, see, from this step, after this, I am going to convert these 2 and 3. These 2 becomes 0 and 3 becomes 1. Then only it becomes an identity matrix. For that, R1 is R1 minus 2 R2. R1 minus 2 R2. R1 minus 2 R2. Minus 2 into R2. 2 into 0, 0. 1 minus 0, 1. R1 minus 2 R2. 2 R2 is 2. 2 into 2 minus 2, 0. And R1 minus 3 R2. R1 minus 2 R1. R1 minus 2 R2. 2 R2 is 0. 3 minus 0 is 3. 1, 0, 3. Next, R1 is R1 minus 3 R3. R1 minus 3 R3. This is 0 minus 1. R1 minus 3 R3. R1 minus 3 R3. 1 minus 0. Second row as it is, right? Third row is 1 minus 0, 1. R1 minus R1 is 0, minus 0, 0. And 3 minus 3. Three or 3. Sorry, 1 minute. We will see. First step R1 minus 2 R2. 1, 0, 1, 2, 3 becomes 1, 0, 3. Second row 0, 1, 0 as it is. 0, 0, 1. This operation R1 minus 2 R2 here. R1 minus 2 R2 minus 36. No, sorry, 2 R3 13 is 26. Minus 26 1 is minus 25. R2 R1 minus 2 R2 minus 10. 0 minus or minus plus 10. 10. And 0 R1 minus 2 R2 plus 6. 2 3s are 6. The next row as it is 13 minus 5 minus 3 and 5 minus 2 minus 1. Next step R2 R1 minus 3 R3. One zero zero 3, it becomes R1 minus 3 R3. Yeah. R1 minus 3R3, 1 minus 0, 1, 0, 0, 3, R1 minus 3R3 is 3, 3 minus 3, 0, 0, 1, 0, 0, 0, 1, it becomes identity, and this is R1 minus 3R3, R1 minus 3, minus 5, 3 into 5, minus 15, minus 25, minus 40, 10, R1 minus 3, 3 times of R3 is 3 2s are minus and minus plus 6, 10 plus 6 is 16. R1 is 6, 3 times of R3 is minus 3 into minus plus 3, 6 plus 3 is 9. And this is 13 minus 5 minus 3, 5 minus 2 minus 1. So this is the inverse of the given matrix. So A inverse equal to minus 40, 16, 9, 13 minus 5 minus 3, 5 minus 2 minus 1. This is the inverse of the given A matrix. Okay. That's all about the problem, and thereby I conclude this video. Thank you.